Okay, let's go ahead and recap what we've talked about in the past two videos in perhaps a bit more of a formal or structured manner. So recovering from format errors, formatted read errors. Recall that our stream is going to have states, and we can ask the stream about its current state. Good is going to return true if and pretty much only if the state of the stream is good. That is, there's no errors. If we're reading from a file, we haven't observed the end of file marker, which we haven't talked about explicitly in this lesson. The reason being is that I really want the loop conditions to be on good and structured in the manner that was described in the last video on this section, and not dealing with the end of file question that you can actually ask stream objects, but instead using good and then this combination of fail and bad. So here's the typical workflow. First off, we're going to attempt to read. So in this case, IFS is simply an input file stream. It's bound to who knows what. Value is an object of some type. It doesn't matter for what we're trying to look at here. It does in the actual read, in the sense that if we're doing a formatted read, we would expect value to be the type of object we're expecting to read from the file. So we attempt that read. Next thing is we check whether or not the stream state is bad. If the stream state is bad, remember that bad's only returning true if an unrecoverable error has occurred. So in this case, well, what do you do? Well, it's going to be dependent on, kind of the context of your application. If this were a machine problem, we'd tell you what to do. If this is a toy problem or pet problem for yourself, you think about, well, what should happen? Bajarnet Stroustrups, I believe, and I don't want to misquote, but his principle of programming book, I believe, suggests, well, you might as well just return from the program with failure, because there's not a lot, that you can do, especially within the introductory course here. Perhaps later on in practice, there's more elaborate ways to maybe look into that a bit more and see whether or not there's some way to get around it. But for now, just assume there's not much we can do. So probably report failure and hope the next time the program's executed, we don't run into a corrupted stream. And again, that could have been based off of the file that the user was provided. It could have been maybe the file where we're pulling the file from, if it's a drive, it got disconnected, but some sort of unrecoverable failure that our program doesn't necessarily need to worry about resolving. So if it's not bad, we can then check if it's fail. Remember, fail returns true if either an unrecoverable error or a formatting error has occurred. By checking bad first, we know that if fail then returns true, it has to happen because a formatting error has occurred. Had we not checked bad first, we would not know whether or not fail is returning, say, true to communicate an error that was unrecoverable, or one of these actual recoverable errors that we've talked about to date. In the case of a fail, we can go ahead and reset the state of the stream with clear, and then we can go ahead and ignore potentially the character or sequence of characters, or go ahead and skip over characters until we observe something in the stream that maybe delineates where one input ends and the next begins, whatever. But we do have that ability to jump forward and then begin attempting this process over. And then finally, in our process, the last thing is going to be to only work with the data if the read succeeded. So notice here it's attempt the read. If bad, probably terminate with a non-zero exit code. Okay, otherwise check if it failed. If it did, clear, ignore, and then we'd come back and maybe attempt another read depending on how this is structured. Otherwise, if we're not bad, if we haven't failed, let's go ahead and actually work with the data because the read succeeded. So for emphasis, all cn.clear, or our input file stream.clear, does is it sets the stream back to good. So on a failure, we might observe false and then true. For say these different states that we can ask the stream about. In the case of writing cn.clear or ifs.clear or some other stream.clear, we're simply reverting back to the good state. However, remember that extraction arm, as we're kind of calling it, it's still latched on to whatever called the failure. So we're not done yet. This is the first step in the process towards resolution. So it does not, clear does not remove any problematic characters from the stream. We're going to have to do that with ignore. So ignore ignores characters in the stream, and we can use it to ignore problematic characters that are causing our reads to fail. This function, as we pointed out, takes two arguments. The first is going to be an integer value specifying the number of characters to skip, up to the second argument, which would be a character specifying the breakpoint. In other words, we will skip some int number of characters or until the character provided as the second argument is observed. Whatever comes first, we then go ahead and leave whatever else is in the stream at that point. So we'd go up to that point. So ignore ignores characters in the stream. The question becomes, well, what should we ignore? How many? Well, how we call ignore is going to be context dependent based on our application. In format errors example 3, we decided to skip over a single character. That was sufficient for the example there. However, if you think about it, well, what if we had like something like our stream looking like, let's just go A, B, white space, 1, 2. Well, maybe we wanted to ignore everything up to the next white space. So if we latched on there, maybe we want to jump here instead of jumping to the next one. And again, this all depends on the format of, say, in this case, the file that we're reading from. If we're expecting our groups of data to be white space delimited, it might make sense to go ahead and simply jump over to the next white space and begin reading accordingly. Or maybe it makes sense to just jump to the next character. Again, it depends on what you want to do. So how we ignore what we ignore, it's all going to be dependent on what we want our program to actually do. So to kind of push you in that direction, here's a couple of kind of different examples to maybe show the utility of this ignore function. So I go ahead and kind of preface this with a question. What if we wanted to ignore all characters up into a specific character, such as a line feed, tab, semicolon, or otherwise? Well, we can ignore all characters until we find the specific one that we're looking for, provided it exists, by doing the following. In order to do this, we're going to need to pound include limits. We can then, to our ignore function, pass the following: std numeric limits, std stream size max. What this is essentially the maximum number of characters that a stream could hold. So what we're effectively doing is saying, ignore everything or ignore up until we observe a line feed, maybe a tab, maybe a semicolon, but essentially don't worry about skipping a fixed number of characters. Just move forward and look and skip to the next occurrence of one of these special characters, provided it exists. So if we don't see, say, a line feed, tab, or a semicolon, we're going to bypass everything in the stream because we specified that, hey, that integer number of characters to skip is the maximum kind of number of characters that could be in this stream to begin with. In that case, it's guaranteed we'd skip over all of them. However, if as we're skipping forward, we see this character, will stop at that point. Everything that came before it would be ignored, and we'd pick up where we left off from that position of one of these characters. And it could be anything. It could have been skip until you see an A, skip until you see a 1, an exclamation point, whatever. How you craft this will be ultimately dependent on, well, what is the format of, say, the file or input I'm expecting from the user? What would be sensible in terms of what should I skip forward to in the event that an error has occurred? And it could be the case that if a read fails, you might just terminate your program on a formatting error because you might view, say, the integrity of the data that you're looking to interact with as being problematic. So again, all of the how you're handling these is going to be dependent on, what your application should do, how mission critical perhaps the data is, etc. But for this course, we'll tell you within the, say, machine problem prompt or otherwise.